going to talk about amounts of reactants in products. It's also known as mass-to-mass problems. So here we have a balanced equation. We've got lithium solid going into liquid water, and we're going to pretend like we've got just like as much water as we need. It is not limiting. And these are our reactants, and they react and they form lithium hydroxide, and that will be an aqueous solution, and it's going to give off hydrogen gas. Now, it would be nice to know if I put in like 10 grams of lithium, how much hydrogen gas will be made? I mean, those are legitimate chemistry questions. Might also be really good to know if you're monitoring your pressure, like how much pressure will be given off by the hydrogen gas. So we need to be able to look at a balanced equation, and we know that we have twice as many moles of lithium reacting as hydrogen gas that will be produced. But now we want to go one step farther and talk about mass to mass amounts. If we had so many grams of lithium, how many grams of hydrogen would be produced? Okay, so that's where it gets the mass to mass name. So here are the steps. And you don't memorize steps, but this should make sense to you. First of all, you must always have a balanced equation. Sometimes an equation is given to you balanced and sometimes it's not. Double check to see if it's balanced by putting your coefficients out front. That's why you had to watch the balancing equation video before this video. So make sure that your equation is balanced and that everything is written properly. You've got to obey the law of conservation of mass, so make sure that your equation is balanced. Then the second step is whatever they give you. If they give you, grams of lithium, convert it to moles. No matter what they give you, convert it to moles. If it's already in moles, step 2 has been done for you. But the reason you have to convert whatever's given into moles is because in step 3, this is how we can talk about the relationship between lithium and hydrogen gas. And that's using the coefficients, and that's the mole to mole ratio. So step 2, we convert whatever's given to us in the problem to moles. And then we use the coefficients to do a mole-to-mole ratio, and that was the last video we watched. And then finally, you just answer the question. Did they ask you how many grams of hydrogen? Did they ask you how many grams of lithium hydroxide? Did they ask you for the pressure of hydrogen or the volume of the gas at STP? You can answer any of the questions they give you. So, balance the equation. Whatever is given, get it to moles. Whatever's given, get it to moles. Use your coefficients. Don't forget this step. Use your coefficients in the balanced equation and then answer the question. Let's do an example. Here's an example of a mass-to-mass problem. You start with 10 grams of lithium and an excess of water, and the question is how many grams of hydrogen can be produced from this? So, step 1, make sure your equation is balanced. This equation is already balanced for you. Step 2, convert what is given to you to moles. So we have 10 grams of lithium. We need to convert that to moles. And by now, this should be like second nature, like writing your name. A mole of lithium is 6.94 grams. All right, so the grams of lithium have canceled and we have moles of lithium. We don't want to know about lithium anymore. We want to know about moles of hydrogen. And so how do we convert from talking about lithium to talking about hydrogen? That's where these coefficients come in our mole-to-mole ratio. We have moles of lithium here. Oh my goodness, this is dimensional analysis. Moles of lithium here. We're going to put moles of lithium here. And we're going to put moles of hydrogen up here. Please don't get lazy and stop using your units. Don't just say moles. Moles of what? Moles of lithium. We get this number by going to our balanced equation, and we put a 2 down here. And our balanced equation shows moles of hydrogen as 1 mole. And so we have done step 3. We've done our mole-to-mole ratio. And then the last step is answer the question. What did they want to know? They wanted to know how many grams of hydrogen were produced. We have moles of hydrogen up here, so moles are going to go down here, and we want grams of hydrogen. How many grams of H2 are in a mole? Well, because it's H2, we have to multiply the atomic mass of hydrogen, 1.01, by 2. And so for molecular hydrogen, the mass is 2.02 grams per mole. So then in my calculator, I would put 10 divided by 6.94 divided by 2 times 2.02, and my answer is 5.82 grams of hydrogen. And that is the correct number of significant digits because we started with 3. This is an exact number. 1 mole of hydrogen is formed for every 2 moles of lithium that reacts. Let's try one more problem. Here's a second example of a mass-to-mass problem. So here we have glucose and oxygen forming CO2 and water. This is a combustion reaction. So oxygen's a reactant, CO2 and water are products. Step 1, is the equation balanced? And I have 6 carbons here, but no, this equation is not balanced. So combustion reactions can be a little challenging to balance, but let me just give you a hint. Always start with the carbon or the hydrogen. Leave oxygen go to last, because it's everywhere. So we have 6 carbons here. Let's just go ahead and put a 6 here. We have 12 hydrogens here. Let's go ahead and put a 6 here. So 6 times 2 gives us 12 hydrogens. Now let's concern ourselves with the oxygens. Over here we have 12 and 6. 12 plus 6. So we have 18 oxygens over here. So far over here we only have 6. So we need 12 more to have a total of 18. And to get 12 more, we need a coefficient of 6 out front there. So now we have completed step 1. We have a balanced equation. All right, step 2. Look at what's given. So they say that you are combusting 856 grams of glucose. And the question is, how many grams of carbon dioxide can form? So start with what's given and convert it to grams. So we have 856 grams of our glucose, and we are going to convert that to moles. So we need the molar mass of glucose, and I've used this enough that I know that 6 carbons, 12 hydrogens, and 6 oxygens, it winds up being about 180.2 grams. All right, so we have done step 1, we balanced our equation. Step 2, converted what was given to moles. Step 3 is let's stop talking about glucose and convert to what we really want to talk about, which is the carbon dioxide. And so we're going to do our mole-to-mole ratio using our coefficients from the balanced equation. So moles of glucose is in the numerator, so we need moles of glucose down here. And what we want is carbon dioxide. So when you have different identities over one another, carbon dioxide and glucose, it has to be a mole-to-mole ratio. The 6 coefficient goes with the carbon dioxide, and a 1 here for the glucose. All right, our unit right now is moles of carbon dioxide. The question asked for grams of carbon dioxide, and so 1 mole of CO2, so the moles cancel, is how many grams? It's 44.02 grams of CO2 per mole. And so I'm done with the problem. I have the unit I want, grams of CO2. So 856 divided by 180.2 times 6 times 44.02, and we will end up with our answer of grams of carbon dioxide, and it is 1.25 times 10 to the 3rd grams. So hopefully you understand the different steps that you go through in these mass-to-mass problems. And next, we're going to start talking about amounts of one reactant and amounts of another reactant and figuring out if one is limiting, and that's going to tell us how much product we can make. So make sure that you understand this concept and tune in for limiting reactants.